once again let me continue with art pressure theories. In the last module I have discussed different types of art pressure qualitatively, that means what is art pressure at rest, what is active pressure, what is passive pressure. Three aspects I have discussed: how wall moves, how major principles to minor principle it become, and what is the failure angle during the angle of the failure plane during active case, during passive case, all those things I have discussed. Now, as I have mentioned that you need to quantify the magnitude of the earth pressure, because in that will be required in the design. So, how earth pressure varies behind the wall and what is the magnitude, that to be estimated. So, for that purpose now we will take one by one. You can see first of all, if I take a typical retaining wall, it looks like this. This is a typical gravity retaining wall. On the gravity retaining wall, that we will have number of forces will be there, and you can see its own weight will act like this, and obviously it will have a normal reaction and soil retained here. So, there will be some active pressure, there will be some soil here, and because of this weight there will be obvious, if there is no other things are kept here, then the tendency of movement of the wall will be towards this direction. So, that means wall will move this direction. So, if wall moves this direction, that means there will be active pressure, and towards the toe side you can see it is embedded. So, when the wall moves this direction, that means this soil actually that means this wall actually it is pushing this side towards the backfill. So, that portion become passive. So, in the same wall itself, somewhere there will be active, somewhere will be passive. How? Because this is the height, because of the huge height, this entire weight will try to push the wall this side, and when it try to move wall this side, that means this side active, and when the wall is moving this side toward this soil, then that means this is passive. So, that means there will be weight of the soil, there will be on the toe side there will be passive pressure, the backfill there will be active pressure, and there will be normal reaction, and of course, since it is moving, so at the base there will be frictional resistance. So, all those forces will be there, and we need to find out everything, and perhaps this weight by if you know the geometry and if you know the concrete unit we can find out, but and this reaction and all friction are related to this only, and so only unknown is this and this. So, to find out this, that means you have to learn how to find out. We know the condition of active and passive, but what is the magnitude, that has to be estimated. So, for that let us take just geometrically, and there will be this is suppose wall. Initially I have taken this this is the wall actually, and this wall I am considering first active case, and because of this active, since active case is the wall movements away from the backfill. So, it is going that way. So, suppose new position of the wall is this, delta is the movement of the wall, and if it moves, and then I can find out the some soil wedge it will move, and because of this there are number of forces acting is W here, and along this failure plane there will be tau, and there will be reaction. So, with inclination of phi, and this side of course active P active. So, all those forces if I draw in the form of a force polygon, then it will come like this, the reaction will be here, W will be here, and if I complete this one, the P A will be this one. And while doing this, what are assumption we made? Frictional force between the backfill and retaining wall are assumed to be negligible. The wall is straight, and the surface of the backfill is D is not required, D is horizontal. That means, we can see this is the horizontal backfill we have taken, it could have been like this also. The backfill is a homogeneous granular material, this is actually granular material. If it is other material, then this will not happen. The failure surface is assumed to be plane, that means, instead of this failure surface could have been like this also, it is not. So, whatever based on this assumption we could visualize the failure wedge, and corresponding to this failure wedge I can visualize the force polygon like this. And if this is the force polygon, then we can relate P A with respect to W, okay, and other things. And if this is a particular condition, and then this wedge actually having at a particular angle beta I have considered, if it angle changes, but different values of beta, I can get different values of force polygon, and for that I will get different values of P A. That means, I have to find out now what value of beta the P A become maximum, then that will become active art pressure. So, for the time being I have considered beta as variable, and based on that I have assumed the force polygon, and then I have assumed the failure wedge, and then based on that I have considered the force polygon. And if this is the force polygon, then little bit of analysis I can do. That analysis will be something like this. You can see that your from the force polygon I can find out P A equal to W tan beta minus phi, whatever force polygon I have got, from there we can get, and I can find out W, that weight of the that is the wedge actually, this is the wedge actually, I can find out the volume and then multiply by gamma, then become weight. So, if I substitute this weight to this in this, then P A become in terms of gamma h cot beta phi. So, P A become this. Okay. So, this P A actually varying, the amount of P A active art pressure will be varying because of what? Because of the beta only. The beta is the variable now, and as I have mentioned that for different values of beta I will get different values of P A. Now, I have to investigate now at what value of beta the P A become maximum minimum or minimum whatever, but we know the active condition it is minimum. So, that means the P A is a function of beta. Now, if I differentiate P A in terms of beta and it set it to 0, that gives you a equation for beta critical, and now solving that I will get the value of beta critical, and that beta critical if I substitute in this equation I supposed to get the minimum art pressure. So, that is the concept used here. So, this is the function if I differentiate P A with respect to beta, and then I will equate to 0, that is maxima minima, that is the condition we do differentiation, we differentiate the function and set to 0, and that I have do, and then if I simplify, then I will see that 2 beta minus phi become 0 become 90 degrees, or beta will become 45 degrees plus phi by 2. That means, this angle whatever this beta we have assumed, and before qualitatively I have shown that active case it become 45 degrees plus phi by 2, whereas in passive case is 45 degrees minus phi by 2, that I will show later on. But for the time being, from this I can see that failure plane angle with horizontal become 45 degrees minus phi by. So, previously I have only mentioned based on our knowledge. Now, you can see mathematically we could find out at what angle this active pressure become minimum, or pressure become active, that is nothing but minimum pressure. So, this beta critical now 45 degrees plus phi by 2, as I have mentioned that critical angle for which the pressure become minimum, that means I can put this beta value to this expression, because beta is actually variable here. Now, I have got the definite value. So, if I put this value, now I get the value of total earth pressure on the wall, and this earth pressure P A become half gamma h square tan square 45 degrees minus phi by 2, and that can be written in a small form P A equal to half gamma h square K A, where K A equal to tan square 45 degrees minus phi by 2, or this is can be written 1 minus sin phi by 1 plus sin phi. So, that means, this is the active case mathematically I got the angle failure plane angle, that is 45 degrees plus phi by 2, and active thrust will be half k gamma h squares and k equal to tan square 45 degrees minus phi by 2 or 1 minus sin phi by 1 plus sin phi. Similarly, if we consider the passive case, that means the wall was suppose was originally here and it is pushed towards this. So, this become the delta or movement of the wall, and I assume again another wedge here and with the angle beta here, and because of the weight and because then when wall moves this side, the P p will be the passive pressure, and because of this weight and passive pressure and resistance, all because of that this resistance, the resistance earlier was phi with this side, phi making phi was this side, now phi become other side. So, that is since it is a passive case. So, if I draw now the force polygon for this, I will get a force polygon like this, that means P p and W and R, and now again similar to previous case, that means for a particular wedge I have got this polygon. Now, if I change the beta to beta 1, then I will get another wedge, and for that I will get another polygon, and for that I will get another P p. Similarly, if beta become beta 3, then I will get another wedge, for that I will get another polygon, from where I will get another P p. So, like that a number of values of P p I will get for different values of beta, and then I have to find out at what values of beta your P p become maximum. There actually we have investigated for minimum, now it is a maximum. So, that actually we can do little analysis and we can find out value of beta for which it become maximum, and then substitute the beta we can find out the value of maximum passive pressure. So, for this let us do the little analysis. This analysis little complicated, you can see may not be. So, P p can be from the force polygon can be written in this form, P p equal to W tan beta plus phi, and you know the W again similarly, if this is the wedge, then volume of the wedge to be obtained and then multiplied by gamma, then that become the W, and this W again substitute to this value, then your P p become this P p half gamma square cot beta tan beta plus phi. Similar to that when it is a maximum or minimum, as I have told you, that if the function, that is a P p is the function of beta now, and this function can be maximized. So, how to maximize that? If I differentiate and set to 0, then I will get the value of function, that particular variable for which it will become maximum. So, if I differentiate P p with respect to beta, delta P p by delta beta equal to 0, then and set to 0 and then simplify, then we will see that phi plus 2 beta become 90 degrees or beta critical become 45 degrees minus phi by 2. Now, that means this angle, that angle will be beta critical will be equal to 45 degrees minus phi by 2. So, whatever I have told in the previous module, that is based on our knowledge that passive case your failure plane will be making an angle with horizontal 45 degrees minus phi by 2, whereas in active case it will be 45 degrees plus phi by 2. Now, mathematically we could prove what is the angle of inclination for the failure at failure plane at passive case. Now, this one if I substitute into the value of P p earth pressure at passive condition, then I will get the earth pressure value P p equal to half gamma square tan square 45 degree plus phi by 2 or half gamma square multiplied by K p, where K p is the coefficient of earth pressure at passive condition, which is nothing but tan square plus 45 degrees plus phi by 2, tan square plus 45 degrees plus phi by 2. So, this one also can be written as 1 plus tan phi by 1 minus sin phi. So, that means we have got K A, we have got K p, and we have got the total thrust for active case, total thrust for passive case. So, all three all two we have both the things we have got, and at rest condition, as I have told you that earth pressure at rest condition, coefficient of earth pressure is 1 minus sin phi. That means, sometime question can be asked that when find out the thrust behind the wall when the wall is prevented from yielding. If this is the question asked, then how we would find out? That means, it is neither a passive case nor a active case, it is prevented from yielding. That means, that is a at rest condition, then that case actually your k naught become 1 minus sin phi. Once you know the one k naught, and then you will be having k p naught actually at rest condition half gamma h square multiplied by k naught. So, like that one can find out. Otherwise, if it is normal condition, if it is mentioned that soil phi value is this, wall height is this, then find out the active earth pressure behind the wall, then simply you find out K A first by using this equation or this equation, and then use half gamma A square into K P for passive pressure and half gamma A square K A for passive pressure. So, these are the things we are getting. Now, this is actually based on some geometry and failure wedge. Now, Rankine is also given a theory for the active and passive earth pressure. From there also we can see that how it can be. So, Rankine's theory, a number of assumptions are there in Rankine's theory. Actually, wall is smooth and vertical, backfill is level. So, these are the major assumption in Rankine's theory, and based on that he has given earth pressure coefficient earth pressure K A and K P, and according to that actually this is the wall suppose, and at a particular point if the your soil element is here, then sigma 1 is actually here and sigma 3 will be here at active condition. And if there is a granular backfill, then what we can visualize for a granular backfill, there is a envelope, and when fully active condition, then I can find out the more circle, and by seeing the more circle and failure envelope, I can relate between sigma 1 and sigma 3, and sigma 3 is nothing but active earth pressure at active earth pressure. That means pressure lateral earth pressure in active earth condition. So, let us look into that. You can see this already we have done this one. So, whatever shown that point in the previous diagram that we have considered the same diagram I can draw here. If I draw an element here, then this will be sigma 3 and this is sigma 1. Okay. So, this one actually normally at rest condition this is sigma 1 suppose, and when wall moves this way, then sigma 1 reducing and finally, it become this. Then this become more circle, and again this was at rest condition sigma 1, and then the wall moves this direction, then sigma 1 is increasing and it is becoming this value, and then so sigma 1 and this is sigma 3. So, this become actually more circle, and you can see both the cases the more circle will be below with the tangential to the envelope. You can see this is the more envelope. So, that means I can, when I will consider active case, I will consider this more circle and this envelope. When I will consider the passive case, I will consider this more circle and this envelope, and geometrically I can find out the relationship between sigma 1 and sigma 3. Now, we can see that different cases, that is active earth cases, the failure plane will be like this, you can see, and it makes with horizontal 45 degrees plus phi by 2, and so these are the failure planes. This is failure planes actually 45 degrees plus phi by 2, whereas for passive case your failure plane will be 45 degrees minus pi by 2. and you can see, as I have told, that active case. Let me take the active case first. If I take active case, and this is actually sigma 1 and this is sigma 3. Sigma 3 will be the minor, sigma 1 we generally call in the major, and sigma 3 is the minor. So, sigma 1 here and sigma 3 will be here, and we know that this is small. So, this is the envelope and this is the Mohr circle. Now, if I see that, if I consider this is center of the circle and this is tangent. So, this become right angle. So, now if I this is phi angle phi. So, if I express sin phi from this triangle, if I express sin phi. So, this become actually this by this, sorry, this by this. Okay. So, this will be, that is this is hypotenuse and this is perpendicular. So, sin phi will be, so this is radius, nothing but radius. Radius is was sigma 1 minus sigma 3 by 2, and this one actually, this will be actually, you can see sigma 1 plus sigma 3 by 2. So, this is actually sigma 1 minus sigma 3 by 2 is this one, and this is actually this portion is actually your, and from here to here, that if I take, then it become sigma 1 plus sigma 3 by 2. So, sin phi, that means this divided by this, if I do sigma 1 minus sigma 3 by 2 divided by sigma 1 plus sigma 3 by 2, and if I please simplify, then it becomes sigma 1 minus sigma 3 by sigma 1 plus sigma 3. Now, if you further simplify, then you can see become sigma 3 will become sigma 1 multiplied by 1 minus sin phi by 1 plus sin phi, and sigma 1, that means when there is a wall here, sigma 1, if the consider element here, sigma 1 here, if depth is h, then this sigma 1 is nothing but gamma times h. So, it is actually sigma h, actually that means it will be gamma h K A, okay, and where this is also gamma h K A. So, K A is nothing but 1 minus sin phi by 1 plus sin phi, or tan square 45 degrees minus phi by 2. Okay. So, this is the one, tan 45 minus phi by 2. So, that means I can find out at any place, suppose this is the wall, and if I know the vertical stress here, vertical stress at this point is 0, then what is the lateral stress? 0 multiplied by 0, 0 multiplied by 0. So, if I consider at a depth here, the depth h, that means your sigma 1 is gamma h, then sigma 3 will be gamma times h multiplied by k. So, that means sigma v will be some value. If I draw the sigma v value like this, then your active earth pressure will be, if I multiply by k, so it will be reduced. So, with depth, if I find out vertical pressure, so this is the diagram, and this is the diagram will be active earth pressure. Okay. So, this is active condition. Now, let me consider the, so I hope it is clear. So, this is the Mohr circle for active earth condition, and this is the failure envelope for the soil. Now, considering the circle, and if I draw joint center to the tangent point, then if I consider this triangle, suppose O A and B. So, your sin phi will become A B by sin phi will be equal to A B by O B, and A B is nothing but radius, and A B is nothing but sigma 1 plus sigma 3 by 2. So, this I have done. So, sin phi become this, and then if I simplify this one, then sin phi multiplied by this, then you can see ultimately sigma 3 become sigma 1 multiplied by 1 minus sin phi by 1 plus sin phi, and sigma 1 you know that gamma h. So, gamma h into 1 minus sin phi by 1 plus sin phi, or gamma h K A, where K A is nothing but 1 minus sin phi by 1 plus sin phi, and this K A can be also expressed in terms of tan, that is tan square 45 degrees into multiplied by 45 degree minus phi by 2. So, this is actually your active case. Similarly, we can consider now passive case. You can see here when it is passive case, initially was sigma 1 was here and was here and sigma 3 become here. Now, sigma 3 is the major principle. So, sigma 3 actually lateral passive earth pressure, sigma 3 is the lateral passive earth pressure and it is big. So, initially sigma 1 here and it was increasing and become this, and when it is reaching to maximum, that become the passive pressure. So, this is sigma 1 and this is sigma 3. In fact, in general though we say the larger one as sigma 1 and sigma and smaller one sigma 3, here actually little to avoid confusion, I will keep this is sigma 1 and sigma 3 irrespective of whatever convention we follow. So, this is sigma 1 and this is sigma 3, the initial one was sigma 1 and final one is sigma 3. This is the way if I take, and sigma 1 becomes sigma 3 in active case, which is small, and sigma 1 becomes sigma 3 in passive case, which is bigger than the sigma 1. So, now if this is the one failure, this is a Mohr circle and this is the failure envelope, and now from the center if I join to this tangent point, now again if I take a this triangle OAB, and if I again sin phi if I express, then sin phi equal to AB over OB, and you can see AB is nothing but radius and OB is nothing but sigma 3 plus sigma 1 by 2, and if I simplify this become sigma 3 minus sigma 1 by sigma 3 plus sigma 1, and again if I simplify, then sigma 3 becomes sigma 1 plus sin phi into 1 minus sin phi. You can see this and that means sigma 1 is nothing but gamma h, and again sigma, and this can be again written gamma h K p, where K p equal to 1 plus sin phi by 1 minus. Now, we can see that K p is nothing but 1 by K A. This is also very easy to remember, relationship between K p and K A, it is K p is inverse of K A. So, and you can see if the K A value is if the angle of internal friction is 30 degrees, then you can find out sin 1 minus sin phi by 1 plus sin phi, but that will be 1 by 3 actually. For if the phi equal to 30 degrees, then K A equal to 1 minus sin phi by 1 plus sin phi, that become 1 by 3, and so K p will become 3, that is 1 by K A. So, it become 3. So, you can see now that sigma 3 become larger than sigma 1 here, you can see the passive case. So, this is the one. So, either considering the wedge and mathematically maximize, find out the critical angle, then find out the active pressure, passive pressure, and then find out the angle of failure plane with horizontal, that is the one we can find out. And by Ankyne theories, actually we know that failure plane that Mohr circle will be tangential to the failure envelope, and from there you consider the that geometrically from here either in active case and passive case we can relate sigma 1 and sigma 3. So, from here actually you can find out that what is the value of K A, what is the K p, and from there we can find out what is the relationship between K A and K p. So, with this perhaps I will stop here. I will see some more aspect when there will be wall is backfill is inclined and some other complication, then how to handle this we will see in the next. Thank you.